There's 4 decimals here in the question, and there's 4 in the answer is one way to look at it. Okay, so that's, therefore, the square root of this is one of these. So what times itself is 0.07. Okay, that took a while. The next one then, if the number of elements in total, so this means the number of elements in total is 20, so that means the whole universal set here is 20. And we have the, this is marked already as 4. The number of elements in G is 12, so that means all of G combined with this middle section is 12. All of H combined with X is 11. So H is 11 here and G is 12. You can write them on the outside if you want. But you need to find what this intersection is. If you add up 12 and 11, you get 23. And you know there's only 16 left between these two is one way of looking at it. So you've got 7 too many. And that 7 too many is because you counted this X twice. You counted for this circle and this circle. So X could be 7. Or you can think about, right, this is 12, take away X. This is 11, take away X. You go 12 minus X plus 11 minus X. That's these 3 together. Equals 16. Why 16? Well, 20 take away this 4. And then you can work out what X is. X is going to be 7. Either way, you want to say X is 7. This is 7. Sorry, this is 7. Okay. Find the number of elements in G dash intersection with H. Maybe a little sketch here if you're not sure what section they're referring to here. G dash is everything outside of G. So I'm going to highlight everything outside of G. And what's H? H is just everything here. Okay, so where do those two overlap? In this little section here, don't they? They overlap in this section here. If I double highlight it, maybe you can see that. So this area here will be, oh, it's 11 take away whatever we found here is 7, so that answer is 4. Okay, write this out in standard form. Right, so let's multiply the 3 times 4 to give 12. Let's add the powers because multiplying, that's minus 11 minus another 8, which is minus 19. But this is 12. We want 1.2, the decimal place after the first integer here. So is it minus 18 or minus 20? Minus 18, yeah, it's getting bigger. So minus 18. Oh, by 10. I didn't put it in there. By 10. Okay. Moving on to question 4. This one caused a little bit of consternation. It was a tricky one. You could take the 32 to the power 2/5 and the q to the power 15 kind of separately. So what's 32 to the power 2/5? We'll do first. The 5th root, so 1/5 is the 5th root. So this is the 5th root of 32 squared. So that's what the 2 is, it's squaring, and the 5 in the fraction is the 5th root. So what number multiplied by itself 5 times gives 32? There is only one, yeah. You only think 2, or usually for these questions, either going to be 2, 3, or 5, maybe 7. So it's 2. So that's then 2 squared, which is 4. So the number in front is 4. Now we deal with the q. Q, 15 to the power of 2/5. Well, power to a power is multiply. So that's q 15 over 1 if you want, multiply by 2 over 5. So multiply these two numbers together. You can make it 30 over 5 or whatever way. You get q to be 6, q to the power 6. 30 divided by 5. Okay, this one I think is a little bit more straightforward. Always go to the lowest base power you can possibly go to solve these. The lowest base here that 9 and 27 have in common is base 3. So that's 3 squared for 9 and 3 cubed for 27. So now I can just compare the powers. They're both to the power of 3 to the power of something. So that's 2n is equal to 3 to the power of 3. So this has got to equal this, which means 2n has got to equal 3, which means n has got to be 3 divided by 2, or 1.5, or 1.5, or something like that. This one's simplifying our surds. When we're simplifying surds, we're always looking for root 4, or root 9, or root 25, or root 16, or something as a factor here. I think root 9 is a factor here, and root 25 is a factor here, maybe. So this is root 25 times root 5, because 5 times 25 is 125. And this is root 9 times root 5. Okay, they just multiply to give the one above. From here, I can say that's 5 root 5, because root 25 is 5, minus 3 root 5, because root 9 is 3, and that, I think, in total gives me 2 root 5s for that one. Next one, so we got an equation here with 7 and 5 in the denominators. How do I get rid of that? I can cross multiply or multiply. Eloise knows what to do, of course.
Basically, you times both of the bottom numbers to make them the same.
Okay, yeah, so you can do common denominator of 35. Yeah, that'll definitely work. You can just multiply both sides by 35, or some people like to think about a cross multiply method here. But yeah, once the denominator is both 35, you can just solve it. So to make the denominator 35, this one must be multiplied by 5, and this one must be multiplied by 7. So we have 7 times 2y plus 1. They're over 35, but you just don't write it, I suppose. And you get 5y, because they're equal, it doesn't matter. Minus 15 is equal to 14y plus 7. All right, solve it from here. Gather the y's over here. Subtract 5 from both sides, we get 9y. Subtract 7 from both sides, maybe, we get minus 22, is it? And then divide by 9. Y is equal to minus 22 over 9. Perhaps if you're in the exam, that is one you double check, because that's a weird number, but yeah, it's correct. So I won't check, but I know it's correct. But definitely in an exam, I'd make a little note to go back over that one, because that didn't look right. Okay, factorization. With two terms, the first thing I look for is it's the difference of two squares. This is not the difference of two squares. First of all, it's plus here, and neither of these two are squares. So then I just look for, right, is there any common factor? Common factor, x. X can come out. What's left behind? Y and 2w. And that's it. This one, a 4-term factorization. So for this one, you would factorize in what is called groups. So maybe like this. Any common factor in the first two, yes, x. And we're left with 2p minus 1 behind in the first two. Any common factor in the second one, yes, 7. And we're left with 2p minus 1. This is exactly what you want to see. Same thing in bracket here and here. So x and 7 are both multiplied by 2p minus 1. And that's how we write it. All right, for a 3-bracket multiplication here like this, probably the easy thing is just go 2 at a time. Just do the first 2 and then multiply it by this afterwards. So that's what I'm going to do. X times x, you can use FOIL multiplication or whatever multiplication you use here. Just make sure you've done all terms by all terms. So that's x times these two. Now I'm going to do 7y times these two. So that's plus 7xy minus 7y squared, I think. These two can be combined before I go on and multiply, because there's 7, take away one of them, so there's actually just 6 of them. All right, and now I'll bring this back in, because I haven't multiplied by this, and I do this all out. So I'll multiply everything by x first, and then I'll multiply everything by 6y. So we get x cubed plus 6x squared y minus 7xy squared. That's the x is done. Now I'm going to multiply by minus 6y. So minus 6 times this is minus 6x squared y. Minus 6 times this is minus 36xy squared. So just, it's about being flawless in your multiplication. And then any like terms, I think there's a few. X cubed's nobody, so he's on his own here. X squared y's, these two cancel out, I think. Any xy squareds, yes, there's 2 of them here. That's minus, what's that, 43xy squareds plus 42y cubed. Okay, I hope that's right. All right, moving on to question 9. This was another tricky one with indices. So different bases, can't compare them yet. Let's get to the same base. So I'm going to say, right, that's 2 to the 3x plus 1. Let's make this 8 2 to the power of 3. And that's the power of 2 minus x. And what you can see here is that once the bases are the same, this must equal this. If they're equal to each other, this bit must equal this bit. It's the only bit that looks different. So I can bring that down. 3x plus 1 is equal to 3 times 2 minus x. And that's now an algebraic, a more normal algebraic equation to solve. So I get 3x plus 1 is equal to 6 minus 3x. Combine x's on one side, we get 6 x's in total. Subtract 1 over here, we get 5 here, and x must be 5/6. So x is 5/6. Next one, this is a pretty straightforward factorization. Common factor, these aren't difference of two squares. So x can pull out, x minus 4 left behind. I don't think I can do any more than that. So that's that one done. Let's continue on. Question 11, more expansions. These ones a little bit easier than the long one. So multiply by 2, we get 6x minus 2 plus 3 minus 6x. I think the 6x's then cancel, and minus 2 plus 3 is 1, and your answer is then 1. This one, let's multiply by 3x first. We get 3x squared plus 6xy minus xy in the middle 2 here, and then the last multiplication is minus 2y squared. Middle 2 will always combine in this style. So we got minus 5xy minus 2y squared for that one. Next one, question 12. A regular polygon, so that means regular means all the lengths of the sides are the same and all the angles are the same, has 12 sides. Work out the sum of the interior angles. That's about splitting up into the number of triangles. So that'd be the number of sides take away 2. So n take away 2 times 180, isn't it? And then I can divide by 12 because there's 12 sides. So this is the number of triangles, multiply by 180 and divide by 12. So whichever way you want to do this, this is going to give 12, take away 2, which is 10. 10 times 180 is 1,800. Divide by 12 requires us to do some long division if we're not entirely sure about how to do that. Okay, let's do it. Set it up. Divide by 12. 12 into 18 goes once with a remainder of 6. 12 into 60 goes 5 times with no remainder, so we are at 150. Work out the sum of the interior. Oh, I've read that wrong. That is wrong. I was working out each one individually. Silly me. This is the answer. That's the sum of the interior. That's all of them added together. I did too much. Okay, an interior angle of a regular polygon is x. Find the number of sides of this polygon in terms of x. Right. So the answer to this is x. So n of a regular polygon is a bit weird, isn't it? Find the number of sides of this polygon in terms of x. Okay. N minus 2, this is our formula. 180 over n is equal to x. Find the number of sides in terms of x. So we want n in terms of x, is it? That's what I'm reading from that. Yeah. So multiply by 180 first, maybe. So I get 180 n's. Oh, that's 118 n minus 360 over n is equal to x. Rearrange, I suppose. Multiply both sides by n, maybe. Okay, 180n minus 360 equals nx. From there, bring the n's to one side. 180n minus nx is equal to 360. So I did a swapperoo there. This added to that side. Factor out the n. 180 minus x is equal to 360. And then divide by this thing. So n is equal to 360 divided by 180 over x minus x, dividing by this over here. That was tricky. Okay, so that's n in terms of x. Over on this side, okay, so a little bit easier then. These are not obviously in order of difficulties. They're very much a mixed bag. So this is, where does the decimal point go? Here it goes right after the first integer, so 5. So this is 5.8. How many decimal places did we move it? 4. By 10 to the positive 4 for that one. This one, we moved it 3 spaces in the negative direction, so that's 8.09 to the 10 to the power of negative 3. Okay, hopefully you're able to do that. Okay, we had this tricky little surds number 14. So let's examine it. Show that this equals that. Okay, so show that. So I'm going to have to work with the left-hand side here. Do my FOIL, your 4-term multiplication. Root A times root A is A. Root A minus root B is root A, root B, or you can put these two together if you like. Added root A, root B is the next multiplication of these two together, and then the last two is just minus B, isn't it? These two are going to cancel because they're the same thing, and you've done it. Voila. Fantastic. Next one, rationalize the denominator. So that's multiplying by the... Well, what do I multiply by?
Square root
Hi.
of 7 minus square root 6.
Okay, maybe. Yeah.
Is it okay if you did an example for question 14a?
You did an example of showing it works like with numbers? No, you're going to have to work algebraically. So that works, that's like, it works in one case, yeah, but you have to show it works in every case, so with the letters. Okay, so let's try Eloise's idea, root 7 minus root 6. So this is our usual how to get rid of a surd in the denominator. So the numerator here is pretty straightforward. It is just root 7 minus root 6. Can these be combined to root 1 or something? No, they cannot be combined to root 1. Now multiply the bottom. So this is a 4-term multiplication again, 2 and 2. Root 7 times root 7 is 7. Root 7 times minus root 6 is, well, minus root 7, root 6, or minus root 42. But then it's going to cancel out anyway because the next one is the positive version, so that's gone in the middle. And root 6 times root 6 is negative 6. So 7 take away 6 is 1. So we've root 7 minus root 6 over 1, or just root 7 minus root 6. Fantastic. Now, work out this. This is kind of a, all right, this is an A, B, and B part 2. So it must have something to do with the original. Now we worked out this to be root 7 minus root 6 from above.
Oh, so it's just all of them above the line.
Yes. So what would this one be?
Root 9 minus root 8.
Root 9 minus root 8, and this one plus root 8 minus root 7 plus root 7 minus root 6 plus root 6 minus root 5 plus root 5 plus minus root 4. All right. So root 8 plus root 8 cancels. 7 cancels. 6 because they're opposite sign. These all cancels. We're just left with root 9 minus root 4. Well, what's the square root of 9? 3. What's the square root of 4? 2. What's 3 take away 2? 1. That's my answer. Is 1. So you have to try to find that pattern. What?
Why is some of them negative and some of them positive?
Because you're adding here between, and then every time we can replace with the minus. So 1 over root 7 plus root 6, we found out turns into this if we rationalize the denominator.
Yeah.
If we do that for all of them, they'll all be the same. Root 5 minus root 4 and so on.
So it's like square root 9 minus square root 8 plus
Yeah,
square root 8 minus square root 7.
yeah, exactly. And then the minus pluses all cancel. Okay, do we just have 15? All right, let's do 15. So we got more sets here. The universal set is integers between 24 and 37, but excluding those. Okay, so you could write those out. That's 25 up to 36, I think. In set A are the prime numbers. So the prime numbers between 25 and 37 are not 25, not 26, not 27, not 28. 29 is one. 30? No, 31. 31 prime? Yes? 33, 35, no, and 37. Okay, there's only 2 elements in set A. Write all the elements of U into the correct parts of the diagram. Okay, so let's get stuck into this. You may be helped by writing them all out. All the square numbers then are 25 and 36 are square numbers, so the answers to squares, 5 squared, 6 squared, is going to be no more. The multiples of 4 then, between 30, excluding. So the first one is 28, 32, and 36 are the multiples of 4. All right, is there anything in the center here? Don't think so. I think the center is a null set. Is there any overlaps at all? Well, there's an overlap between B and C of 36. I can see that. So 36 goes in here. I think there's no overlaps. A is kind of, well, prime numbers. You'd expect that, of course. 29, 31 here for A. B then is 25 and 36. So 25 goes here. And 28 and 32 go here. Oh, 28 and 32. Don't think there's any overlaps. We put all the rest that haven't been mentioned out on the outside. So 25 is there, 26 is not there, 27 is not there, 28 is in there, 29, 30 is not there, 31 is there, 32 is there, 33 is not there, 34 is not there, 35, not there either. Well, they're most on the outside then. 35 and 36 is there. Okay, that's them done. Now, final bit, write the number of elements in A union C intersection with B dash. Okay, so this is, a diagram is good for this. Let's look at two diagrams. Let's look at A union C first of all. That's the easier one, I think, to draw. A union C is anything that's in here, I think. So that's A and C, they're those two together. So anything that's shaded there. And B dash is maybe a trickier one to draw, not really. B dash, anything outside of this circle. So that's all of this, and all of this on the outside. That's everything outside of B. So this one is B dash. This one is A union C. All right, where do those two intersect? I think in just these areas, yeah? Does that follow? So how many elements are in these double shaded areas? How many? 4. So the answer is 4. That's the number of elements, not listing the elements. Okay, we're on to the last section of the non-calculator section. All right, this is a difference of two squares. There's nothing in common in factors, so that might be a giveaway. There are two things that can be squared. So 3x to be squared and 2y to the power of 8 to be squared. That's a tricky one. So there are the two things to be squared. So in each bracket then, we should know how to finish difference of two squares at this stage. Well, hopefully that's how you finish difference of two squares. Noticing what is squares and then difference. So 1 minus 1 plus. And the second last one here is a, factorizing by grouping again. So if we common factors, I would probably rearrange this. I don't know if it's necessary, but I'd put this and this together. Does it work out otherwise? Maybe. 6CD minus 9D. I've noticed they have something in common. This one, not really. But let's see what we can get out of this one. I think we can get a 3D out of it. We're left with 2C minus 3. Now, I want this to have 2C minus 3 in the bracket as well. So what do I factor out of it? 1. I'm going to factor 1 out of it, which is kind of a little trick more than anything. And 2C, that's also 2C minus 3. I can change the order. That's okay. Writing in different orders is the same. And now I have 3D plus 1 and 2C minus 3 as the two things. Factorizing by grouping, that's called. And this last one, make x the subject of this formula. So I'll probably just multiply everything by a plus 2 to start, because I don't like that. So that's 3ax times a plus 2 is equal to 1 times a plus 2 minus 2x. So don't forget the 1 also has to be affected. So I have 3a squared x when I multiply this in, plus 6ax is equal to a plus 2 minus 2x. What am I trying to make the subject? X. So that's, I pull anything with an x over to one side and everything without an x on the other side. The only thing that I'll move is maybe this added to this side. So I have 3a squared x plus 2x plus 6ax is equal to a plus 2. That's just that on a little journey over here. And then final stage, I got 3 x's. I only want 1 x. What do I do? Factorize, that's right. 3a squared I'll put it in this order, 6a and then plus 2, a plus 2, and then that is multiplied by all this, so I can divide all this over the other side, and we'll have x equals a plus 2 divided by 3a squared plus 6a plus 2. Vision, that's tricky, that's why it's worth 4 marks. All right, maybe I'll leave the calculator section till Monday. If you haven't done it, do get it done now. And